So, this right here is a loudspeaker. You'd have surely come across a speaker in your life at some point. Well, many speakers come in different shapes and sizes, but what we are showing right now is a traditional speaker and the components any speaker would usually consist of. So now let's dive deeper to get a further understanding. Okay, so a loudspeaker uses the principle of electromagnetism. Now, what you see labeled as the permanent magnet is a very strong magnet, and around this magnet is a coil, which will also act as a magnet, and it will have its own magnetic field only when the current passes through it. So, if there is no current passing through this coil, it will not have its own magnetic field, and it will not be attracted, nor will it be retracted. So, when we pass an alternating current supply, the direction of the current will keep changing, and when the direction of the current keeps changing, the polarity of the coil will keep changing as well, resulting in the coil to oscillate to and fro. So, what I want you to know is that a loudspeaker, due to this very reason, will only work in an AC power supply and not a DC one. The coil inside needs to vibrate to and fro. This is the reason why speakers vibrate, and it is these vibrations that are set up in the air that originate sound. Now, there is a cone connected to the coil, and as the coil vibrates, the cone will also vibrate. Now the cone will push the layers of the atmosphere, which it is in contact with, outwards, and then pull it inwards, effectively setting up a series of sound waves in the form of compressions and refractions. If the frequency of these increase, the frequency of the sound waves will increase as well. And if we increase the strength of the AC supply, then the coil and cone will move with greater amplitude, hence increasing the sound. So, now you know what happens when you turn the knob on the speaker to increase the volume.